This computers, and then we will just say share screen and just interview. Everybody can see my screen, right?
Yes.
Okay.
Hey, Professor, it sounds like there may be some students that are not allowed in. Do you have like people on like a queue?
Let me see. There's just one. No, two now. Okay. Takes time because what happened? We're gonna use something called pulse width modulation. And pulse width modulation, it's something famous and even controlling robotics elements and even controlling motors and so on. There is something called PPM, there is something called PWM, there is something called DOS, there is something called micro DOS. All of those are protocols for controlling motors. But the most common one is called PWM, which is a pulse width modulation. And I already have some slides and lecture for you guys for it. So, but I'm gonna show you my code so you can understand what I want, and then I will write it down as usual, and that's it. Okay?
Copy that.
So here, look. So what is pulse width modulation? So the experiment I want. Oh, there was experiment. So the experiments I want is the following. Do you remember the two RGB LEDs,
Yes.
the two colors, right? So those colors, each LED it has three different pin, right? It has one for red, one for green, one for blue. Do you agree? As you can see in front of you here, right, in my Vivado, right? I created one. It's
Yeah,
called
you're
PWM core, right? That one. Then I instantiated three times into the PWM here, and then I have also a clock skew, something like a IP, like a clock generator PLL, and I combined them together, and I was controlling the variety of the colors can come out of the LED based on the resolutions in the PWM. Let's open the core of the PWM. Here in front of you, I clicked on it, right? So the core is what you already have. I make it parameterized. Can you see the code?
yeah, we can see PWM core.
Yes. So I made here something called R resolution and I put it 8. But later on in the top, I can actually write it. Do you guys agree? Because there is something called parameters, there's something called local parameters. Local param is basically used for permanent, you cannot change it basically. While parameters, you can overwrite it when you actually instantiate it in a different what context. Now you know what is the input and output ports inside the core. So inside the core, I'm taking the clock as an input, the reset as an input, and there is a signal, I call it load. And then, I have something called duty, and this duty, it will be from the size of the parameters. So if I say 8, so that means it's going to be 7 to 0. 7 to 0, that means 256 resolution. Like, you will expect number to be from 0 to 255, right? Then there is an output, and this output is PWM, basically what I expect to be an output. Definitely, if I'm gonna build a counter, it's better for me to have what? A temporary, and this temporary is R count, and then the duty load is another counter as well. Then I built using behavior models the first part, which is basically the counter used for the R count. Then the second, I actually take the R count and I start counting based on the duty load, which is a value that's coming from a different counter. What is this? Is literally in the PWM. Do you remember the positive edge and the negative edge? Do you remember the clock? In the clock, you already have high, low, high, low, high, low, right? So the size of the high is equivalent to the size of the low, right? You know what I'm talking about? The clock is just like a pulse, right? So when you go high, the duration of that part is equivalent to the low. This is the difference of the clock. But PWM, no. That part of the high, we call it duty cycle. The part of the high, we call it duty cycle, which is the active part of the clock. in there's some sensors, they need the duty cycle to be 1 millisecond, but maybe the off it will be 14 milliseconds. Maybe there is another sensor, it want that's on to be 20 milliseconds and the off maybe 1 millisecond. So if you notice, the clock it's supposed to be a special case from the PWM. That makes sense? So the PWM is more generic, which is basically the ratio between on and off you play with. But the special case is basically the clock because the definition of the clock, the on is equivalent the off in the term of number of what unit of time. What I'm saying makes sense to you? Hello, hello.
You kind of lost me at that last part. Right? I mean, I get that the clock is essentially a fixed 50%, like
Yeah,
on and off.
let me try maybe draw it in front of you. They're gonna be much better, right? So let's go in a Zoom. Same meeting ID. Join. Hmm. 1 3 3 1. Okay. Mm, Movement. Okay. Now I'll go share content, share screen. And then I'm gonna stop sharing here, right? Can you see my new screen?
Yeah, we can see your tablet.
Okay. Now let's go into the here. Okay. Do you remember the clock? How the clock look like? It's already here on, off, on, off, on, off. Right? That part is if it's repeated, it's actually T, and then this is another T, this is another T, and the frequency is 1 over T. Do you agree? What is the properties of this clock? This time is equivalent that time. So this is T on because you are high here, right? On, and this is T off. So the T is equal T on plus T off, and T on equivalent to T off. This is a special case from the PWM. So the PWM, which stands for pulse width modulation. I already put the lecture there, so you guys should watch it. So how it works, generally, this part we call it what duty cycle, and then that part is generic, the off. So some sensors, that's supposed to be like this, and some sensor like this. There's some other sensors, is like this, and then like this. There's other sensors, you are like this, and so on. But if you notice, all of them almost look like the shape of what? The clock, right? So what is the conclusion out of this? The clock, it's supposed to be a special case from the PWM. You agree now?
Yes.
Okay. So how we can build such a kind of shape? So how we gonna make this on, off, on, off, on, off, right? It's not really hard. It's basically based on what? You're gonna have a duty. You're gonna compare with the duty. If number of count is less, you keep yourself on, and then if it's above, reset the counter, then the off will start, and then you return it back to be on and off and so on. Because think about it, right? For instance, if I have here a signal, one second. If I have here a signal like this, right? And I want to measure this. How can I measure it? I will measure it based on my clock. Do you agree? Why? I will say, oh, you know what? This is 1, 2, 3, 4, 5 cycles. But I know what is my cycle. My cycle, for instance, because I'm 100 megahertz, right? 100 megahertz, that means my cycle is going to be 1 over 100 megahertz. Then, times this, I can tell you what is how much time this. Make sense?
Yes.
Okay, perfect. Now we're gonna go back to my code so we can match what I'm saying. All right. So here we stop sharing, and then we start sharing again. What Vivado. So look at the code, right? Now what I did here comparator. See? So I created actually what I created the counter that I'm talking about. It's counting, and that counter it's basically based on the size of the resolution here, right? R is size, and there I was making 8. If I go down here, I'm saying that I am R count and I'm comparing with my duty, which is the size of the on, right? If I'm less than the duty, keep me 1. But if not, make me 0. So the output of this comparator, this always block, it will produce the PWM on off based on what I want. That makes sense? Now, the duty load, what I did, I make it incremental duty load. I didn't make it fixed. Like you can load it by your hand, put like 15, 16, whatever. Why? Because I would like the glow coming out of the LED to be what? How to say spectrum. So that's why I came and I made what? I made it a counter with loading. Do you remember the loading that we made in one of our labs? Here, if you notice, I said, make the duty load as a counter, and I had the luxury to load the duty inside that counter, and that counter will be counting. So by this way, I end up doing what? Making a starting point of the duty, but I'm changing with the variety of the size of the duty load. What I'm saying makes sense.
Yes. Yeah.
So far, anybody has any concern or any problem? Because this is the whole entire lab. Did you see this code? This is the lab. Why? Because the rest is hierarchy, right? Top. If you open the top, you will find that I have the final top is basically what? Clock, reset, and then I have 3 load. Load for the red, load for green, load for blue. So I can make the spectrum as I want. Then the duty, I already make a duty, and then I already have a 3 different output wires, RGB. From your point of view, those RGB will be connected to what? This one will be connected to the R on the LED. This one will be connected to the G on the LED. This one will be connected in the B of the LED, right? And that will be what? Switches. And that will be what? Buttons or switches. It's up to you. And the clock and reset, it's a clock and reset, right? Now, I'm sure if I run 100 megahertz, my eyes will not recognize the changes. Do you agree? So one of the way to do it is to make a clock divider, or you can make the trick we made about this clock manager. Do you remember? But the problem with Clock Manager, I'm using switches. Do you remember it was 5 switches to make 32 different options, right? I don't have that luxury because I'm using 13 already here, right? So I will be running out of switches. So that's why I decided to use PLL. And I discussed that PLL before in front of you in one of the lectures. So here, you know what I did? I actually instantiated an IP. It's called what? Uh, Clock Wizard. And you know, you can see it here. It looks different than the rest because it's a clock wizard. It's an IP. How you get it? Normally, you get it from IP catalog. If you go IP catalog here, you just say, you know, you're supposed to have this already there in material, but you know, I'm gonna show you quick. It takes some time, you know, my laptop sucks. Anyway, clock wizard, wizard. See that one? You click and so on, watch the video, you will figure out, you know, not this video, the video for the materials, you will understand how I did it. But anyway, back to the point, I have now the IP. See, that's the IP. And this IP is not ours. It's just generated from the catalog, right? We put it in, instantiated. Then, you know, we created a clock, and that clock, it came here, which is called clock locked. The To make the story short, you know what is lock and slow and all of this? Basically, the IP is called PLL, phased locked loop. This IP, you give it 100 megahertz, then you know it will attenuate or amplify the frequency. So it has the luxury, by the way, to amplify frequency because it's an analog component. We are now calling analog inside digital. Okay, but then you know to transcend to move to the new clock, you have to have a kind of a transition and a steady state. Do you agree? So in the transition, the locked signal it will be low because you know it's telling me you didn't get the desired frequency you want. But once the desired frequency will come out of this block, the lock it will be high all the time. So what I did here, I'm saying make my clock a real clock when the lock is what exists. Otherwise, it will be zero. So that means don't run anything on the block because I might hurt or destroy some elements inside the chip. That makes sense? Then I instantiated this PWM core 3 times, as you can see in front of you. Did you see them? I put here the clock lock, clock lock, clock lock. Reset, reset, reset. Then, you know, each one, it has its own load. Do you remember? So load R, it's going to be on the R. Load G, it's going to be on the G. Load B, it will be on the B. Then, you know, the duty is the same because end of the day, we don't have that many switches, right? So we can actually make the starting point of all of the internal counters, as I say, but the frequency will take care of the rest. Then, you know, the output of the PWMR, output of the PWMG, output of the PWMB will be coming out. And then, you know, if you look into the constraints file here, you will see everything. Here's the clock, here's the clock. Then, you know, I use switches, as you can see, from 0 to 13, and I load RGB. I use it also as a switches. So end of the day, I use all of the 16 switches. And then, you know, the reset, it will be a button. Sorry, here the RGB for the one of the LEDs. Do you remember this is 16 and 17? I just used 17. And then, you know, the switch, it was this one, which is a button, basically, it's not a switch. What I'm saying makes sense. Somebody text me. Let's see what he wants. Will this be the last of the semester? Yes, sir. That's basically what I said in the beginning. This is our last lab. Okay. Now,
Uh, so I got a quick question. So I know in one of the previous labs we used a button for the load. What is the reason that we're utilizing switches for the load this time? Is
uh,
that just to hold the load enabled
no,
in a
no, no,
sense? Like,
no. There is no real scientific reason. It's just playing. So, you know, you have the luxury to make R and GB, load RGB to be buttons. It's your choice. Actually, I would recommend to play with it. What does it mean? You try one with load as a switch. You try one maybe without, you know, with buttons, and tell me what is the difference from your point of view. You're just, you know, we are exploring the board. You know what I mean? I mean that's a part of education. For you guys, do you have any specific question? Do you have any concern? Do you have any problem? Definitely, you can even make more fun if you want. You know what I mean? Like, did you see this duty thing? You can actually go connect the duty into the seven segment display. So you can even see the number that you're writing as a decimal or hex or whatever. I mean, there's a ton of expansion of this lab you can do, which is not really hard for you, quote unquote, because you already got more difficult stuff before. One of them is this alien calculator, it's a bit tricky. Huh. Any specific questions so far regarding the Lost Lab? Hello? Any question? Any problem? Any concern?
I just want to re-clarify. You said that the procedure for implementing the IP clock is already covered in that pulse width modulation uh, video or in one of the videos
Yeah,
that
I
was
mean, it's
released.
one of the videos across the semester. I mean, the summer. I mean, here, I can click it for you. Look, and double click on it. It will take some time to open. Because I was using older version of Vivado, It's just asking me to reset. That's fine.
I noticed it said your synthesis was last updated in 2020.
Mm-hmm. Now it's okay. Now it's opening. See? It's a very simple. See, if you click on that thing, did you see how it looks like? It's telling you what clock options, clock output clocks, port renaming, PLL, whatever, right? So here in the option, I just said PLL. PLL, it's a luxury of a device that it can allow you to produce for 7 or 6.7 megahertz up to 450 megahertz from the 100 megahertz. And the MMCM is crazy. It can even take you beyond 800 megahertz. But it's not recommended because end of the day, if you are running 800 megahertz on this board, it will be fried because you don't have active cooler. You don't have like a fan and heat sink in the top of the chip.
Right.
Okay. Now, outclock. How many clocks that I want? That block it can reduce up to 6 clock parallel from 100 megahertz. I just asked it to give me 7 megahertz. That's it. And that actually making the uh, experiment running in 7 megahertz. So I'm taking 100 megahertz from the XDC and feeding the pulse width modulation with 7 megahertz. That's it. Then port renaming, leave it as it is, PLL setting, and so on. Done. And then you just go and say what OK down. It will synthesize and automatically it will open for you what the Verilog coming out of it, which is the instantiation part, which is basically the part that I instantiated here, as you can see, button here. See that part?
Okay.
Okay. Let's see some people text here. So, well, we have till the end of the day to submit the last lab, right? I mean, you have up to next week. Submit all of your lab, but once I will put the grade, there is no negotiation. That's my reply to the text message. So, please, who didn't finish, who finished. But I want, if nobody actually have any problem with that, um, every single, right by the end of the folder, your subfolder, as in group A, whatever, Say that every single lab, you tell me lab zero, we work together. Lab one, we didn't work together. Two, we work together. Lab four, we work together. We didn't work together, and so on. Is it clear? Because I have to be fair. I'm not gonna say names,
I,
but some people actually do a lot of work by themselves, and then other people take a credit. I'm not gonna give names, but yeah.
you're saying you want
A
just a
summary.
file that's okay, okay.
A summary file by the, let's say that you finished lab seven. That's lab seven, right? So you finished lab seven, so you already had 0 to 7, right? That means eight you across the semester. So you come and make a table, and you put your name, your partner name, and then you make a long line. This have been done by me and him, or just me, him.
Okay. And then I know you said all the labs submitted by next week. Next week being Wednesday or Friday of next week.
Wednesday. Everything by Wednesday it need to be done.
All right, copy that.
Okay? And the finals are gonna be the same thing as I mentioned in the announcement that I sent to all of you guys before. Look at the announcement that I sent at the beginning of this semester. It was putting all of the dates and everything. For the second midterm that you already guys had it, right? I'm gonna grade it in this weekend, and you guys will see your results. Your grade, I'm sorry. Okay, Luke? Is it clear to everybody what I want? How I'm gonna be grading you as usual. 50% demonstration, 50% what? This bench. Because all of you guys actually go through the recording the video and so on, which is convenient for sure. Hmm. Any question before I start writing in the Discord as usual?
I think we're good.
Okay, super. So I will say stop sharing here. And then I will go open my Discord. See, right? Lab 7. This is our last lab for summer 2024. We have to remember to submit all of our work in the summer before 10 p.m. Wednesday. 1 second. That Wednesday will be what?
Wednesday would be the 7th, August 7th.
Yeah. 7. Also, as to create a PDF file with a table showing the name of the admin and following by to column one for each member with seeing who participated in the uploaded board clearly. Who for the lab 7, please watch the video will be uploaded here shortly. It focuses on the PWM. It will control the spectrum of color on RGB and grade 50% them and 50% on demonstrating the test bench. For those who worry about this particular and we have one button which settings ah I meant button for reset and which is for duty and again white for the your option is your choice. It's button or switch. Okay. Any other thing that you guys like me to add? Is everything clear? Hello.
I think so.
What about the rest of the people? Hey guys, do you have any question, any concern, any problem? Hmm?
Everything seems clear, Professor.
Okay, so I wish you guys all the best. God bless you. And it was my pleasure to work with you guys during the summer. And I'm looking forward to see you in person during the coming semester. Thank you.
Thank you.
Thank you.
Thank you, Professor.
God bless you guys.
Professor.
Yes.
Professor,
Yes, sir.
do you mind staying on? I just